the specification which has been shown by our Honorable Prime Minister and which say that we have to do a few things in a few years. Now, we have also discussed that we have made the way, we have some vision in between what we have to do, that has to be assigned and that has to get done in terms of science and the technology which are needed. But in this, there is a very important component which happened in the year 2024. Should be the beginning. The National Space Science Symposium, which had 6 sections. These 6 sections not only had deliberations in terms of scientific results or space technology, we also had a lot of breakout sessions, and there have been lots of deliberations from each section in terms of what are the outstanding problems in the different domains of space science and what we should do. That was the thing. Now, being completed, the matter would have been only for a select set of scientists who are doing serious science. There is a so-called serious science. And then there is a serious level. But it has to come down to the people who will lead the program and follow the program, as I have told you, that age group. And to reach that age group, you are the people as a teacher, that you will tell the students, inspire the students. So here let me tell you that in this Space Science Symposium, these 6 colleagues of mine, they have been an integral part of 6 sections in the Space Science Symposium. They represent 6 important chambers of space science. It is not only one chamber, there are multiple chambers. So I would like to introduce Dr. Mukunda Gagai from SPL, Space Physics Laboratory, Vikram Sarabhai Space Center. He has been associated with the Space-Based Meteorology, Oceanography, Geosphere, Biosphere Interaction session. I will tell you why these people are chosen, because they are officially the rapporteurs of the session, and rapporteurs have got the advantage. Since they have to report everything, they have all the information, and they are very bright colleagues, so they read between the lines. And their inputs have helped us to come up with an outcome report of the National Space Symposium. After my knowledge, we have never come out with an outcome report. This is the first time we have done, and they have given the inputs. And wherever rapporteurs were not present, they could not attend the Space Science Symposium. In those cases, we have asked either the conveners or the co-conveners to join. Okay, so next one is Dr. Kishore Kumar. He has been the convener. He is also from the Space Physics Laboratory, Vikram Sarabhai Space Center. His session was middle atmosphere, atmospheric coupling dynamics, aerodynamics, and climate change and sun earth interaction. Then we have Dr. Satish Tampi from the same institution, and he was a co-convener of the section Solar and Planetary Sciences, and he heads also in SPL, the Planetary Science Division. And then we had Dr. Girish, who is the Deputy Director in the Science Program Office, District Headquarters. He has been associated with the Astronomy and Astrophysics panel session in this symposium. Then Ms. Rita Gadilia from the Space Application Center. She has been the rapporteur in the enabling technologies for space exploration. Not only science is important, you have to have technologies which will enable you. That was the session she was there. And then last but not the least, and most important, the student session, where my colleague Prapti Mittal from IIRS, this is the gold mine of all the data and a lot of other activities. She was associated thoroughly with the student session. So she was the rapporteur in the session. So with this, time is less, 5 to end. Theme is like this, I hand it over to you. After having spent 5 days of time with the National Space Science Symposium with your respective sessions, you have come across lots of discussions and the outstanding problems, what we should do, all these things. You also have come across different institutions in the country, other than ISRO, who are working in their fields. Now, having this background, instead of going to much of a scientific jargon, remembering that we are having lots of teachers who are also sitting on gold mines. And their gold mines are perpetual gold mines because year after year they will have students. Now, what message would you like to give to them, telling that in your vertical, how do you feel that India as a country will offer opportunity for the young generation in your domain of the National Space Science Symposium in terms of number one, brain research, and number two, job. So I start with, sorry, I will go by this panel. I start with Dr. Mukunda Gavi, over to you. So maybe you can restrict yourself to 5 minutes, then if time permits, we'll come back. Let us see.
So the second which was a state-based meteorology, oceanography, newspaper interactions and climate change. So in the from each of these parameters, each topic is itself a broad research area. So most of the research what is going on in the country is like index of the media data set, whether it is from ground measurements or it is from the space environments. But the most important requirement is that the table itself is telling the space meteorology, oceanography, geosphere, experiments. All these are integral part of the climate change. So we have taken now more than 5 billion years to come to this level in this 7 period. Our job is to have accurate information of these small analytic parameters to understand the feedback processes and how to precisely predict the climate change. So we have different results over the ground locations. For example, one meteorological parameters mostly composition or media, oceanic parameters like geosphere, X-sphere, all components we can have information in specific locations. But how get all this information from satellite that change? So we are talking about showing the different satellite sensors that is people or those are already in the field. But he said how to derive meaningful information on all these parameters from the satellite sensor is very challenging us. So what I always required first we should have an understanding of how these can be translated into the technique. For example, okay, I'll write it short. Give an example. For example, how radiation is getting emitted in the atmosphere. So this information may be a very small experiment. Completely calculated to your putting in this thing, and later you are passing for the so the software development is more concentrated, radiation detection will be more. After person we know it is not only the concentration, it is more and also the radiation. Now it's a new principle that radiation of radiation using the error atmospheric column, and that is how we are designing the radiation from solar radiation in the atmosphere. And the energy of the solar radiation and the atmospheric system that is one of the most important components to understand the climate change. Now, what is the other technology getting information we are getting onto the ground based instrument? The technology is understanding we have to show into the space based system. So now, when we are putting a sensor in the satellite, most important thing is a series of vector bands. So this is the only we have that how many different channels we can use and how we can relate the solar satellite generating different dimensions. So based on this, we have to test the legal parameters. It is a very challenging task, multi-unit view, multi-pixel resolution, and very high resolution spatial document. And then we have already formulated how should we get all the components of the atmosphere or the surface or different geographic domains, and then how can we talk to the understanding of the physics of the atmosphere. So it is to develop technique, in the technique to generate data, extract the data using physics, information become more physics to develop your technology. So that is for the target. So new technology need to look into that question. Now, I will say what is the research on how is the AM technique. So now we are huge data sets. Like if we want to 1 GB by 1 GB, we use data set. If you get down to 0.1 GB or 1 GB resolution, there's a huge data set we are generating. So how we can automate this process is when we are taking a rating on a satellite, how we are inviting to a meaningful parameter and then processing to SMB into a climate model. So for one favor, the speed of the rating transfer model. Another rating transfer model. In one model, if it takes 1 second or so, it will take 18 hours to complete one global simulation. So now how we can bring it to 1 hour? So it is a data we are taking. So we can processing data meaningful information, but we can't play the transfer or the climate model. And then more important is the regional specific climate model. That is what now urban scale climate model is very important parameter. So and the prediction, which only to be or this is kind of
So here I have one question. Just if you have to tell one teacher here, when they go back to their students, what message should they tell in terms of career? Maybe 1 minute you can tell.
yes, now we are getting a lot of satellite data. So there should be a methodology that we develop how to automatically count the data from the facility API, automatic programming interface. And then that satellite data can be recorded in the meeting because satellite is taking only a raw data. So this can be coupled to multiple satellites.
From which satellite, which website?
So this is depending on what the site objective.
How to search?
Yes. Site objective is what is the field. For example, you are doing a change, for the some change, according to you have to go to a particular satellite. There are many that is for example or different for example cloud. So this is satellite data. Communicating the data. Also, the coupled to the other parameter. So multi-sensor is on automated some of the processes where they go the parameter. And it's ready the data to set up its for
Mosaic website. So as I was about to tell, ISRO's own Mosaic website tells about whatever he has been telling. Only thing I would like to tell you, teachers may go back, search for the Mosaic, okay, and see what kind of data are all available. Start doing small things, then only other things also will go. Okay, many information are there. Okay, we'll go to the, we'll go by this list. Dr. Kishore Kumar, your views.
Very good evening. First of all, this is the best time to be a space enthusiast because ISRO is going with multiple missions. So, coming to my area of research is I'll be working in the middle atmosphere and have represented a space weather component of National Space Science Symposium 2024. So, what happens is most of the space assets, all this satellite and all those things, what we call as a space asset, it is about 300 to 800 to 36,000 kilometers also. This is what we call near Earth space. Here, this particular space, we have something called space weather. Space weather, like weather for the lower atmosphere, will be measuring temperature, humidity, and wind speed, that kind of a components. Whereas to have a space weather, we should be knowing what kind of a plasma exists there, what kind of a density exists there, visual density. So these particular aspects to study so that we can protect our space assets. So it's very important. This particular region, wherever this near Earth space, is impacted by two main events. One is something which goes from the lower atmosphere, like a big thunderstorm is there, a cyclone is there. These kind of events generate something called atmospheric waves. These waves goes and perturb the state of the space. At the same time, there are some events which originate from the sun, like we call it as geomagnetic storms, solar flares. These things comes and puts lots of energetic particles in the space weather. This is very harmful to the space satellites, especially. You know, knowing recently there are multiple satellites have fallen down by Starlink satellite. This because of geomagnetic storms. So we study these things in and out. And in India, there is a very good group in both atmospheric sciences as well as space weather things. In many of the universities, there are special groups who are pursuing it. So how to get into this field? I mean, the thing, if you want, there are two types. One is the technology where you will do the engineering and come to this particular kind of a thing where you can develop the sensors to protect these things and to measure the space parameters such as the plasma density, even winds, neutral wind, all those things. We make a sensors. This is one stream where we are looking for electronics and communication engineers, mechanical engineers for some kind of stability of the satellite, those things. And for science side, pure science side, we are looking for physicists, especially because the charged particle, their motion, their interaction, how the spacecraft charges due to these geomagnetic storms, all those things for physics background people are more apted for this one. So, and how to get to touch it, this is like touch with this kind of a subject. It is not exactly space weather is not a subject in many of the colleges, we know that. So in MSc physics students, most of them last 6 months or 3 months, there have been projects. So many of the labs in India offer this project first. In our space physics laboratory also, many people comes and some of them while going they will have some flavor of this one. And we have seen that at least 20 to 30% of people come up into a research. Not only in India, there are some of the people even getting admissions into Max Planck based on this particular project. So if any space enthusiastic student is there, get in touch with this kind of a national lab like I told Space Physical Laboratory, Physical Research Laboratory, National Atmospheric Research Laboratory. Apart from this one, some of the IITs like IIT Indore and IIT Roorkee, there are very good faculties where they are offering projects under space weather and middle atmosphere sciences. So this is main thing.
Okay, thank you. Before going to the next speaker, coming to Mukunda, suppose somebody wants to do research in atmospheric science, what are the institutions would you recommend? And to get a job in this, what are the institutions will you recommend? Can you please shortly the note?
So at present in the state is about so we have many components from the lower atmosphere to middle atmosphere to upper atmosphere. So I will be talking about the complete upper atmosphere program. So for atmospheric science, we are doing a research in the country for generating a regional resource database and the regional directory of atmospheric resources. That means atmospheric resources, the small particles, that is the or whatever small particles that are not in the atmosphere, produced from the natural or anthropogenic sources. How much they are in the atmosphere, how they are getting transformed because of different anthropogenic processes. No, it is required to have a
Institution name only, because we don't have details.
so this is the laboratory and the business growth authority.
Other than that, other than SPL, I think NAL, okay. Channel, what else? Shillong.
So these are the factors actually
IITM will not do. IITM is more for application side. Those who predict the weather. Very difficult job in tropical latitudes. So these are the we have not left anything.
IMD not offer the research positions, but they can give you the data. Yeah, for operational.
IMD is the place for getting job also. That aspect also. Yes, yes.
So what problem he was mentioned that there is a collaborating networking institutions. Whatever is ISRO is funding for a network of the there are some people who have spoken join the research program.
Okay. So this is very good information. So we'll go to the next speaker, who is Dr. Satish Tampi. Over to you.
Yeah. Moving on. In NSS, actually, I was the co-convener for the session, which is solar physics and planetary sciences. Now, let me put actually, see, currently we are in IIRS, it is Indian Institute of Remote Sensing. Sorry. Yeah. Now, what if this I want to emphasize what is a remote sensing part. See, when you see the title which I was sharing is actually solar and planetary sciences. In fact, actually now if you look into the entire community, this all everything merging under one heading called the heliophysics. Because the reason being actually the sun, that is actually the main driver for our entire planets. 8 planets and planetary bodies you take it, I think that is one drive. But when I put the word remote sensing, see, so far we are all as a scientist, we are so convenient actually sitting here and doing something, whatever we have, tools we have, we are remotely looking into the sun and telling about all these, whatever the things which you know as a physicist or as a scientist. But unfortunately, we should know one thing actually, as far as sun is there and our solar system is concerned, sun is giving its energy mainly in 3 forms. One is the radiation, which already we are all comfortable. That's the one actually we are applying for the remote sensing. And we are getting a lot of information. But apart from that, equally it is giving charge particle. That's what we call the solar wind. And that one is the magnetic field. Unfortunately, charge particle and this magnetic field, we cannot do the remote sensing techniques. For that, you have to have in situ measurements. Means physically your instrument has to be available there, then it has to measure, and then only you can get the data. So that is actually that portion. Means basically, if I say means like 3/4 or maybe more than 50% of the information related to sun is actually still we don't know. Means we don't know our own energy source. That is a real fact. So currently, but you know that actually I'm fortunate to work with the IIRS mission. Not only the IIRS mission, including Chandrayaan 1 onwards, I am part of that thing. Chandrayaan 1, Chandrayaan 2, Mars, and now currently in Venus also. But authentically, I can say that actually currently we are in a good position to tell many things related to this, all the 3, radiation, particle and field. Well, we have built up data of our own from our ISRO side itself, because Chandrayaan 1, you all know that actually Chandrayaan 1, we had limited data from our mass spectrometer, which was in the Moonlight probe, and also we had data from SARA payload, which was actually collaborative with the Sweden. That data we have, and in Chandrayaan, more than 1 year data we have in our ISRO's repository. Similarly, coming to Mars, we have more than that also, we have more than 3-4 years data we have. Then Chandrayaan 2 currently we are getting, Aditya we are getting. All these things, what I'm saying actually, there we have institute. This basically I'm telling about the institute measurements data. Radiation, of course, we have plenty of ground-based observatories. If you go to PRL, if you go to other IIRS, all these things, they have the ground-based telescope, they have plenty of data. The only thing is actually we should have a comprehensive approach. See, if you want to tell something about the solar or band system, we should study all these three. Then only you can tell a comprehensive picture. For example, now Kishore was telling one of the thrust area which actually now ISRO, not only ISRO, the entire science community looking for just space weather, because we have to safeguard our own Earth. The space weather is basically it is the effect actually due to the charge particle, if I say. And the events which is coming from the sun, like coronal mass ejection, solar flares, all these only actually modulating the environment of the planets. So you know that actually what Kishore was telling is related to the Earth case. Same thing is applicable to our planets also. Because if you categorize our planets, we can categorize into 4 things. What are they? First thing is actually planet with atmosphere and with magnetic field. For example, Earth case. Earth is having a very good atmosphere plus a strong internal magnetic field. So there the conditions are different. How sun is interacting is different. But there are planets with magnetic field, no atmosphere, like Mercury. It don't have atmosphere, but it has strong magnetic field. There are planets like Mars and Venus, they possess atmosphere, they don't have magnetic field. That is the third scenario. And another thing is really the planets do not possess magnetic field or do not possess like moon. So as a planetary scientist or as a solar physicist, we have to see how this radiation particle field, how they are actually coming and modulating these different 4 types of planetary bodies. Planets are planetary bodies. So the interactions are different. So do we know all these things? For example, so far actually we were restricting to our Earth case only. You know only about our Earth case atmosphere because that was limited, because our technology was limited. But that consensus is not there now. We have been very well beyond that, and now we have built up data. But how much actually we are using it? See, problem is ISRO scientists, we cannot do everything. Because for example, when I started developing instrument for Aditya, I know that actually it took 12 years to release one instrument for me. And I cannot do all the things. So what we need actually from academia side, from other industry side also support actually, because we have data that actually you should voluntarily come, and like what our Nas was telling, see, data is already there. Now Prapti will be telling where the data is. For example, if I tell about the planetary and solar data means, we have a ISS, that is the Indian Space Science Data Center. There actually we have a site called the Pradhan right now. And if you go, and she will tell all these things now, how to get the data. Plenty of data is there. So if anybody want to, like from academic side, if you want to pursue it actually, you can contact through that side. There are some protocols you have to follow, but you will definitely get the data. You will get the quality data, which is in par with the other agencies. Let me repeat it. Because now we are also actually coming to that range only. So that data, because our data is being now used by other agencies for their calibration purpose. They can understand. Like today morning itself, actually, our respected unions are telling how actually we were doing, ISRO was doing separately, and how our discoveries are different than other countries. The reason being actually here, though we are actually late, but we are coming with the latest things. So my only request actually to pursue solar or planetary science actually, we should pursue all the radiation, particle and field data, which is currently available from remote sensing techniques as well as institute techniques. Request that all of you please join and handshake with the scientists so that you get the data, make use of your students from academic side, see that actually we get to a very good science outcome. This is our point I want to make it.
That's actually one point. Now, which institutions do they want to get job? Where will they go?
No. See, the first of all thing is that actually now, even as a, there are like already my told actually, initially for the student side actually, we need first funding for the pursuing the research. For that, there are like response baskets, everything. Job. Naturally, for example, in SPL, like we get students actually, they are, once they are completing PhD, they are getting placed in nice position PDF abroad also. Even in India also, those who are having really good output actually, they are getting jobs in very good institutes. So the job as far as those who are having, quality stuff are means definitely they are getting. I cannot say that specifically, because if you pursue science actually, there are more than hundreds of reputed labs in India itself. So like that you will get chances. I'm telling only about the institute and organization. But there are universities also, academics are also that.
Before going to the next speaker, just one addition. To be specific, around space physics lab is one lab where people can do job like we were doing. Then we are having PRL, physical research laboratories, another place. We are also having different other institutions like, okay, given the universities where some places planetary science is taught, not in all places it is taught. And then we are having some institutions like Indian Institute of Geomagnetism, where they work mostly on the geomagnetism, but they have started working on the planetary magnetospheres also. But currently in India, planetary science institutions that offers job, the number is less, but this number is coming up. Is this also
Yes. That's what I'm saying. Now actually it is merged actually. That's one mistake made actually. See, for example, let me give you an example. Aditya mission, there are 7 payloads. There are 7 payloads. If you look at the first biggest payload is made by what? IIRS, Indian Institute of Astrophysics. They were exclusively for the astronomy and astrophysics. But now they are actually coming into the sun side. No, it is scattered as a star. No problem. Second thing is IUCA. That is the second biggest payload. That is called the SUD, Solar Ultraviolet Imaging Telescope. That is made by IUCA. They were Pune based in the University Center for Astronomy and Astrophysics. Then PRL, they made one instrument. That is particle instrument. Then our resource center is LEOS. Then SPL, then our SAG. So like that, different institute from ISRO and outside actually we are jointly working on this thing. Just it is nothing like that actually one ISRO side we are working in. But here it is now, everybody understand the scientific community because it's a very small group. They understand actually we have to do like a collaborative way only. Otherwise, by independently, you cannot address. Because for example, let me tell you, I told you I have space that is CME. CME is such a huge event in that Earth is a small dot. And if you have one satellite, what you can tell about CME? You will be only seeing where you are observing. So if you want to tell a comprehensive picture or topography of CME, you have to have multiple satellites and multiple vantage points. So in that case, if I do send a spacecraft and I cannot tell you, okay, some CME, that time, what are all the simultaneous satellites available? Let it be NASA, let it be JAXA, let it be ISRO, no problem. We should do a joint thing so that actually we will get multi-point observations, and then you take all it, you stitch it, and you tailor it and make a science. That's what we will tell about the CME.
Okay, just to summarize, I'm sorry to stop because a lot of things are there to be told. I agree with that. Take home message is go through the websites which are available and telling to the teachers. These all informations are there and tell your students what all can be done. We name some institutions. These are immediate openings. Okay, we'll go to Dr. Girish.
Thank you.
So if you beyond the system and take it the sign, which is not a living us. So in astronomy also we study everything from star in how it is born to its death and how it combines and how the radiation is given, how the star two stars when they collide together, how they know the radiation and everything. And how most of our operations are through remote, because we use the automatic radiation starting from radio to order to gamma rays and beam. So one of the major required what I very proud of is the presentation made on a black hole which is rotating at the highest possible speed for the black hole below the radiant limit. If it goes beyond that, the centrifugal force itself can break the black hole. So we have helped it that particular target, that particular black hole. So we have presented this target. So I'm not going to take you into what are the things which you can do with what are the things that are available for astronomy expertise. What I just wanted to tell you is with the launch of exposure in X-ray fish, we have actually covered all the 4 pillars of operational astronomy. So starting with the imaging, then the time variation and energy variation and also pole variation. And coming with available ground-based observatories in India. I'm not going to beyond India. So because it will be like it will take 1 hour to 10 minutes just to list the names of the observatories. So within India, we have lot of many observatories like radio and Cheshmani and IR and the optical in Handley and the IIRS, telescope, and even IUCA at one point had a telescope for optical observations. And currently, ISRO is actually putting up multiple telescopes through India for daily movement, which can also be used for astronomy. And here, as was mentioned, they have colors and other telescope air observations. Like covering all these things, India has a fantastic India provides an interesting opportunity for both students and the people who like to actually get involved in astronomy or studies. And at the same time, coming to instrumentation part, not exactly science part, instrumentation part, there are multiple missions planned by ISRO and other authorities, and so we are looking for many people to work on that. Just to give an idea, as of now, we have at least 3 or 4 science missions, astronomy missions, planned at different stages, and not even they are clear, but at different stages of digitalization and development. So this each one requires hundreds of people to work on it. I from the Satish can actually tell you how many people were used in involved in Papa's Papa instrument. You can actually multiply that by minimum 100 to give you an idea of the number of people we are looking for. Okay, so I'm not going to go there. So now I just want to tell you the opportunities available. So India has many astronomy institutions. See, in if I start on the north, sorry, the topmost. So in the Women University, there is the astronomy department, and coming to IIT Guwahati, Kolkata, the French University, SFOs, and Mumbai has 3 institutions. Bangalore has 4 astronomy institutions, and Hyderabad, Osman University, and PRL, which are so like this whole India, you have many research institutes wherever there is physics, and sure they will be actually doing astronomy also. So the opportunities are very high. So in addition to the astronomy alone, I just want to give you 2 examples where the people who have done PhD in astronomy are employed. So one of the examples is one of my junior who did astronomy, finished PhD in astronomy, and he did statistics. So now he is actually employed in Bombay Stock Exchange. Okay, so another one. So he is his PhD from Rama Research Institute in Radio Astronomy studying Parathas, and he is involved in the Shell Corporation, who is looking for regular fuel leader and oil leader. So in addition that you have many other opportunities in addition to the individual calculated like lecturers and professors. So it's not that okay, you have to have a restrict to own the astronomy. So even I did my PhD in astronomy, but my PhD is physics. So that opens me many more doors than what is what if we can be more astronomy. So you have the opportunity to enter any of the any business very analysis. So particularly big data and how to interpret the results. So if the opportunities are infinite, you can reach that. That's all I want to say. Thank you.
Thank you, Dr. Girish. So the message is in astronomy, astrophysics, scopes are better compared to the other fields. But that is the fact at present. Other fields are atmospheric science to some extent there. Other ones, astronomy very good. Planetary is still growing. Like this, it is happening. Let us see what our colleague who is next. I think Ms. Arpita, what do you have to say?
Thank you, Dr. Girish. And a very warm evening to everybody sitting here. So I come from Space Application Center. The name says it's just the application center, but actually what we do at Space Application Center is part of ISRO. We manufacture utensils, we make payloads, and we do the processing of the data that is applied to those payloads. Then we have scientists who work on those data to derive meaningful information. So those technology, this is we have actually here. I don't know what else streets are teaching, but the application center we can give you the flavor of physics, we can give you the flavor of microbiology, we can give you electronic engineering, we can give you computer engineering, we can give you mechanical engineering. We have all the streets that exist in that can naturally exist in space. We have that. So what we do at Space Application Center, we adopt niche internship programs, and those internship programs depending on the interest of the organization and control the student, we give them the problems to solve, and we mentor them. So different things we talk about what are the venues outside. So outside rather than initiate with the competition, since we are open in the space sector for the private players, we have got many industries that are coming up right now. In 2067, already started and Lama. Many of you we have Rostam, many are located in Bangalore and some are located in Hyderabad. So like offices in the end. So it's not we have to stick to one particular organization. We have revenues and assets. Technology and we say, only what the what is will do and what the departments will do. But since we have opened up like this, we already opened up like the data. So now this gap has created in the law because our departments are working on the model and writing the intervention, but it's pretty much. So right now we have the only is particular three because I have done this particular not this degree. So we have only many to keep exploring and expanding the domains because the lines are becoming very clear and now going time. The biggest thing I got from this e-learning techniques is they're not e-learning like present in the data which we have able to solve earlier. So it has opened up the very planet of industry for everyone to know. I think the very good example is we don't have same data, we don't get all about phases. But if we talk that we don't have data, we are not sure what to do. But like if we don't have we should keep on exploring. So during this COVID, we all were in lockdown. So that is trying to learn this data. And I was not sure where to get the data. So do the regulation, like do you have it? We have so many societal problems that we can solve through the data available in that. We can, like, for example, know what the problem is very big crisis and industries. So we only share data. We have to data available with us, like how the population is run. The more the population becomes, the more what it is usually. So that's why you have to keep the mind open and solve the problems in the betterment of the society. Because technology is immense, not like we have in the generation program, where we have a very more explanation. We are talking about these and so it ends. Yeah,
Out of several important things she mentioned, two important things which I captured. Number one, job opportunities are opening, not only through the companies and institutions, but also through startups. So that is one take away for the students. Second thing is, so we have to keep a watch on what are the startups. At present, there are 250 plus startups. The number is growing. So when by the time students also grow, we should the startups have to keep a track. Second point is, she was telling that I have learned this, got a degree in this, that doesn't mean that I will do this. Learning is the process of how to learn. That way. Okay, after having listened to all these things, Bhakti, you have got the opportunity to feel the temper of the student community. Nowadays, what is your take on this?
Thank you, sir. Good evening, everyone. So I was part of student session, and since we have the faculty and the students here, I can tell you that there were students, may not be from hardcore research domain, but still the work was so good. I can motivate you by telling that they were into all the domains. All the domains, what is already covered was also part of student session. They were using the space science data, Earth observation data. They were talking about the launch vehicle capabilities. They were suggesting the new payloads. There were also students who had participated in analog missions. So analog missions are like simulation of Mars conditions and such on Earth. And they live there for isolated duration, in an isolated environment, learn resource management better. So they have even participated in such domain. So the area is quite vast. It's not just one domain. Let me tell you more about space science data, which I am part of. So we are ISSDC, Indian Space Science Data Center. We have data of all the Chandrayaan 1, 2, 3 missions, Mars Orbiter mission, Aditya L1, Exposat, and Astrosat. Our website, you can visit our website, issdc.gov.in. We have the Pradhan portal, which offers you most of these missions and also other websites. You can see different payloads here. Let me give an example of OHRC. It's a high resolution camera on Moon, which is one of the best throughout. Like the resolution here is 25 centimeters. So when we say 25 centimeters, it's a 100-kilometer orbit. We can see a 25 centimeter block as 1 pixel. If you can understand it, if when we are in a flight, we are around say 10 kilometers. So when we see with our eyes, can we see a 25 centimeter block? No. But we have a camera on Moon which can see 25 centimeter by 25 centimeter as 1 pixel. So we have that good instruments, world-class instruments, and that all data is freely available on our websites. All can use it. You have to make a simple registration. You need a mail ID to give it. We have Pradhan portal and others too. Register yourself, give your credentials there, and start using this data. We also have TMC, terrain mapping camera, which is again visual data, so many would like to explore it. You can use, recently there was a hackathon held. So one of the challenges given was to identify the craters using this data. So those who are saying computer science, what do we do? So this is one of the examples. They use this data, used classification algorithms and identified the craters. Other than that, I'm from computer science domain, so I would like to add here, since there were a lot of discussions that how to motivate computer science students. There is an instrument class that does the elemental maps. So there are students who have used this, again from computer science domain, applied clustering techniques and identified which location has which element in higher quantity. It was on Moon, right? So there's a good scope for all the domains, including computer science, to explore these areas and do the research and technology part too. Job-wise, I think most of them have already covered. Yeah. So we have opportunities in ISRO, we have in other research institutes and private industries, all of them.
So before it is 5:10, can I go up to 5:16? Okay, because
Can you just
not 1 minute, 30 seconds, because I have to ask them whether they have any questions.
I just want to add and what you're talking. So with OHSC data, you can actually see the Apollo landing module picture, okay, which is there on the moon. So that is the kind of resolution we have. So what I wanted to say is when I was talking about astrometry, I like to you say that what we observe the sky is only through the moon. Not like that. India has the largest meson detector in the country. And percentage accurate beauty, which is one of the best in the world. Okay, and so this I just wanted to add, saying that it's not only in the observation of using electromagnetic waves, even the particle detector.
Other messenger source.
Thank you.
So before we close and summarize, we will take some 3 questions from the audience and very quick answers. Okay, anybody wants to ask?
What is the procedure to apply for corporate?
Get engaged. See, I will tell you, very quick procedure is, before procedures, very quick thing you can do is, we are having 3 websites, you can remember the names. One is ISRO, Indian Space Science Data Center. If you don't remember, just Google, you will get, which has the space science data and astronomy data. There is MOSDAT, which has the Earth's atmospheric data. And we have Bhumidhi. Bhumidhi has the surface data of Earth. Okay. Now, they are giving a lot of data from which student can do projects on their own. They don't have to apply for any formal permission from ISRO and waste their time. Okay. And for ISRO, And other websites also, there will be names of the scientists who can guide. So you can always write a mail if you seek any clarification, and it will be very good as a student project. Then we are having support cells, AstroSat support cell and Aditya L1 support cells. Just remember the term support cell and attend Aditya L1 and AstroSat. You will get a lot of information, contacts of the people who are running the show. Those are the ways. And coming to the projects, go to the ISRO website. In the ISRO website, there is a drop-down menu called opportunities. Under opportunities, there are many things. Go on browsing, you will be able to get the information about how to do projects in ISRO, and also this internship, whatever we have been discussing, those are there. Only one question, or time for only one question, otherwise I will summarize because there are other children. Okay, last question, yeah.
We had a session national intelligence during the week that working on the question. How do you reshape the prediction model, especially when the major disasters happen? Because there are the results that are going and this
It's a very domain specific question. I can try to answer from my common sense. Okay. There is a kind of disaster is happening. One disaster is what? Say some landslide is happening. Why will it happen? It will happen if there is some instability there. If instability is there, those are some possible regions where this type of thing can happen. So we have to see whether there is any tectonic fault. Okay, if there is some kind of a signature where the soil is loose, basically there are certain parameters which I do not be the best person to answer. They are classified as precursors to tell whether this kind of disaster is going to happen. And ISRO, IIRS and NRSC, National Remote Sensing Center, they have come up with, as far as I know, not only the map of the natural disaster areas, but also mobile apps. The app adds in. So real time you can see with the app currently how things might happen, with what probability in what time scale. So this is the way things happen. So there will be many questions that I have to close. To summarize this discussion, I would like to tell a few points. First point is, we discussed about the job opportunities and we have come to know the names of many institutions. Apart from that, the space reforms have opened up new job possibilities in the realm of space technology because of the startups. So that is one takeaway you can tell your students. Number two, I have spoken about the MOSDAQ, ICTC and Unity websites and told what kind of data are available there, how students can use them. And once they use them, they are getting the flavor of using real data, which they can use for their career progression. Third, it is telling your students different verticals of space science. Many of them are under the impression that space science is only black hole, which is not correct. So what are space science? These people are sitting, all of them are not working on black holes. So tell that space science is much bigger. And lastly, Dr. Pravin's talk, whatever he said, integration of this information plus that information, maybe he will be able to give the soft copy also to you. Maybe through IIRS it can be given. All these lectures are available in YouTube, and IIRS will take initiative to release the videos. And his lecture and this panel discussion, once you combine, there's a very good direction for the students, but they can do what India can offer for space. Thank you, that's all.